Look up tonight. Find the constellation Orion. In the upper corner of the hunter's shoulder, there's a star with a faint orange-red glow. It's easy to find, and people have been finding it for thousands of years. Ancient sky watchers in Egypt tracked it. Arab astronomers named it. Sailors used it to navigate open water centuries before satellites existed. For almost all of that time, it was simply known as a massive aging star burning down toward its final act. But new data released in 2026 just changed that story completely. This star isn't alone. Something has been hiding in its atmosphere for years, and scientists only just found the proof. Stick with me for the next few minutes, because what researchers uncovered here rewrites a piece of how we understand dying stars everywhere in the universe. And if this kind of deep space mystery is your thing, subscribe now, because this is exactly the kind of story this channel digs into every week. The star is Betelgeuse. To understand why this discovery matters, you first need a sense of scale, because most people underestimate just how enormous this thing actually is. Betelgeuse belongs to a class of stars called red supergiants, the largest stars that exist. Its diameter is roughly 700 times wider than our sun. Put another way, if you deleted the sun from the center of our solar system and dropped Betelgeuse in its place, its surface wouldn't stop at Mercury. It wouldn't stop at Venus. It would swallow Earth, swallow Mars, and keep expanding outward past the asteroid belt, possibly reaching all the way to Jupiter's orbit. One star sitting where our entire inner solar system currently sits. And it's dying. That part isn't new. Betelgeuse is in the final stretch of its life. When a massive star burns through the hydrogen in its core, the core shrinks and heats up while the outer layers balloon outward, cooling as they expand, which is why the star glows red instead of white-hot. Eventually, when the core can no longer resist gravity, it will collapse in an instant and rebound in a supernova, the most violent explosion the universe produces. When Betelgeuse finally goes, it will be visible in broad daylight, brighter than the full moon, casting shadows at night for weeks. The last supernova visible to the naked eye from Earth happened in 1987, and it wasn't even in our own galaxy. Before that, you'd have to go back roughly 4 centuries to find one people could actually watch unaided. So when Betelgeuse blows, it will be the most spectacular sky event in recorded history. The only real question has always been, when? For years, the answer kept getting murkier. Betelgeuse was dimming and flaring in ways that didn't match a simple aging star. It was shedding huge amounts of material. Some scientists floated the idea that the countdown to its explosion might be measured in decades, not millennia. Then, in late 2019 and early 2020, Betelgeuse did something that made international headlines. It dimmed harder than anyone had ever recorded. Its brightness dropped so sharply that news outlets everywhere ran the same question. Is Betelgeuse about to explode? When astronomers dug into the data, the real explanation turned out to be something nobody had directly witnessed at this scale before. Betelgeuse had blown a chunk of its own surface into space, a massive cloud of hot plasma that cooled into dust and blocked its light from Earth's view. It had essentially convulsed, throwing off billions of tons of material, and then it slowly started recovering. That event, now called the Great Dimming, left a real puzzle behind. Betelgeuse has long been known to pulse in brightness on multiple overlapping cycles, about 180 days, about 230 days, about 400 days, and then one much longer, slower rhythm of roughly 6 years. 3 of those cycles matched known physics, a giant star breathing in and out as it burns down. But that 6-year cycle never fit any model of a single pulsating star. Something else had to be causing it, and for years, nobody could prove what. In 2025, 2 separate research teams working independently landed on the same explanation at nearly the same time. Betelgeuse isn't alone. There's a second star orbiting it roughly once every 6 years, and that orbit carries it directly through Betelgeuse's enormous outer atmosphere. Researchers named the companion Siwarna, drawing on the Arabic origins of Betelgeuse's own name, which translates to the hand of the giant. Fittingly, the companion's name means her bracelet, because that's essentially what it does, circling its giant partner the way a bracelet circles a wrist, roughly every 6 years. The strongest confirmation came in January 2026, when NASA announced that nearly 8 years of continuous Hubble Space Telescope observations, combined with ground-based data from the Fred Lawrence Whipple Observatory and additional facilities, had captured clear, repeating evidence of the companion's presence. A research team led by scientists at the Harvard-Smithsonian Center for Astrophysics described what they found using a simple image. Think of a boat cutting through water, leaving a wake behind it. As Siwarna moves through Betelgeuse's vast outer atmosphere, it does the same thing, dragging, compressing, and stirring a dense trail of gas that expands outward every time it completes an orbit. That wake shows up as a repeating shift in the spectrum of light coming from Betelgeuse. Subtle changes in wavelength that reveal gas being pushed around in a pattern lining up perfectly with Siwarna's roughly 6-year path. The pattern showed up not once, but at least twice across 8 years of Hubble data, always appearing shortly after Siwarna passes in front of Betelgeuse from Earth's point of view, then fading as it swings around to the far side. Lead researcher Andrea Dupree summed it up simply: finding this wake means scientists can finally start to understand how a star like this evolves, sheds mass, and eventually detonates. So what does Siwarna actually look like next to a monster like Betelgeuse? It's unremarkable by comparison. A hot, blue-white star with somewhere around 2 to 3 times the mass of our Sun. If the Sun were a beach ball, Siwarna would be roughly that same size. Betelgeuse, at the same scale, would need to be the size of a stadium sitting right next to it. Siwarna orbits at a distance comparable to where Jupiter sits from our Sun, except because Betelgeuse is so absurdly large that safe distance actually places the companion inside the giant's extended outer atmosphere. Every orbit, it plows straight through that outer layer, stirring the gas and leaving its wake behind. Then, in July 2026, came the next piece. Using the Very Large Telescope in Chile, one of the most powerful ground-based optical telescopes on Earth, a research team directly imaged a candidate object sitting exactly where orbital predictions said Siwarna should be. The result was published in the journal Astronomy and Astrophysics. That image lined up precisely with the timing models built from years of Hubble data and earlier ground-based detections. A second confirming observation hasn't happened yet, because Siwarna has now swung back around to the far side of Betelgeuse and won't be favorably positioned for imaging again until November 2027. Telescope time for that follow-up has already been secured. Even so, the combination of 8 years of atmospheric wake detection, 2 independent brightness cycle analyses, and now a direct imaging candidate has been called some of the strongest evidence yet that Betelgeuse is part of a genuine binary system. Here's where the story takes an honest turn, because this discovery doesn't actually mean Betelgeuse is closer to exploding. It means the opposite. The unexplained 6-year brightness cycle, once treated by some as a possible warning sign of an imminent collapse, now has a mundane explanation. It's just Siwarna stirring the atmosphere on schedule. Updated models that factor in the companion's gravity now place Betelgeuse in a stable helium-burning phase, a stage that can last a very long time. Current estimates push the supernova timeline out to tens of thousands of years, possibly closer to 100,000. The companion didn't shorten the countdown. It explained away a false alarm. There's also a darker footnote to this story. What happens to Siwarna itself? Almost certainly, it gets destroyed. When Betelgeuse's core finally collapses, the resulting explosion will release more energy in an instant than our Sun produces across its entire 10 billion year lifetime. Siwarna, orbiting inside the outer atmosphere, won't survive that. But it may not even make it that far. Tidal forces between the two stars are expected to slowly drag Siwarna inward, and researchers believe it could be swallowed entirely within roughly 10,000 years, long before Betelgeuse ever detonates. If that happens, the engulfment itself would be an unprecedented event with no real historical parallel. This discovery also reaches beyond just one star. Astronomers have a long-standing mystery called the red supergiant problem. Theory predicts that red supergiants should be the most common progenitor of core collapse supernovae. But when scientists check historical records of stars right before they exploded, the progenitor often doesn't match what theory expects. In one case, confirmed in early 2026, a massive star roughly 2.5 million light-years away seemingly vanished without any visible explosion at all, apparently collapsing directly into a black hole in what researchers described as a quiet fade-out rather than a dramatic blast. Hidden companions like Siwarna may be part of the explanation. If many dying supergiants secretly have companions shaping their mass loss, their rotation, or even getting swallowed before the final collapse, that could account for why real dying stars don't always match the textbook picture. As Andrea Dupree put it, other red supergiants, showing similar long-cycle brightness patterns, may have companions of their own that nobody has found yet, simply because nobody was looking for them before. And there's a strange, almost humbling detail buried in all of this. The light Hubble is analyzing right now left Betelgeuse roughly 650 years ago. When that light departed the star, it was the 1370s. The printing press didn't exist yet. Europeans hadn't reached the Americas. That's the light scientists are reading today to reconstruct the orbit of a companion star that humanity didn't even know existed until last year. The next chapter is already scheduled. In November 2027, Siwarna will reach its widest apparent separation from Betelgeuse, as seen from Earth, the best possible window to image it cleanly. Multiple observatories, including the Very Large Telescope and Gemini North, already have time booked for that moment. If those observations match what 2025 and 2026 have already shown, Betelgeuse's binary nature will move from strong evidence to settled fact. So tonight, if you step outside and find that reddish glow on Orion's shoulder, you're not just looking at a dying star anymore. You're looking at a pair, a red supergiant so large it would swallow our inner solar system, locked in a slow gravitational dance with a companion a fraction of its size, orbiting once every 6 years through the outer edges of its dying atmosphere. Nobody alive today will see it explode, but every new observation gets us a little closer to understanding exactly how and why the biggest stars in the universe come apart.